This is lesson 2.2, multiplying polynomials. In the last lesson, we looked at how to multiply a monomial by any size polynomial. This is also what you did in Math 9, and we just used the distributive property to do these simple multiplications. In this lesson, we're going to learn how to multiply any size polynomial by any size polynomial. There are 4 methods that we're going to go over and that are in the book, but you only need to understand or use one of them. So I'll share which one I use most often, but you don't have to understand them all, just pick the one that works best for you. The first is called the distributive method. How you use this method is you multiply the entire first polynomial by every single individual term in the second polynomial. Once you have it set up this way, then you just have monomial multiplication by a polynomial, which we already know how to do. So in this first step here, you see that I have x squared minus 2, whatever the first polynomial is, and that gets multiplied by the first term in the second polynomial. And then I have it written again times the second term in the second polynomial, and then I have it written again times the last term in the second polynomial. Then I can do my multiplication like I already know how to do. So 3x squared times the first gives me 3x to the 4. 3x squared times the second gives me negative 6x squared. So I calculate each of these multiplications on their own, which I know how to do using the distributive property. Once I get to this step here, I'm almost finished. I just have to collect any like terms for my final answer. So I've underlined those in green. The x squared terms can be combined to give me minus 3x squared. And for your final answer, make sure you always write the polynomial in order of descending power. So this means the highest exponents go first, and then you go down, ending with the constant. So that would be your final answer. This one is a pretty good way to make sure you're multiplying the correct terms by each other, but it can take up a bit of space and a bit of time because you're writing out a lot of multiplication steps. The second method is the vertical method. This is very similar to doing long multiplication by hand, and I'll show you an example as I explain the steps. So first, you're going to stack the polynomials on top of each other with the longest one on top and the polynomial terms in descending order of power. So if I have this binomial times this trinomial, I'll put the longer or the bigger polynomial on top and then the other one on the bottom, kind of like I'm setting up a long multiplication question. Like if I was multiplying 123 times 54, let's say, you would set it up like that, right? The bigger number on top, the smaller number on the bottom, and they would be stacked on top of each other. So the other thing I reminded you of is make sure the polynomials are in descending order of power. In this case, they are already, so that's fine. But sometimes you might have to rewrite the polynomial so that they're in order of descending power. Then you're going to perform your long multiplication by multiplying each term in the bottom row by each term in the top row. So what I've done here is I multiplied y by every single term on the top polynomial. So y times 4y squared gives me 4y cubed. Y times negative 5xy gives me this. Y times 2x squared gives me this. So again, just like if you were doing long multiplication, you start with this term and it multiplies by every single thing on top. And then the second row here was from the 3x. The 3x is multiplying by every single term on top. What you'll note is I have a space here because you have to line up the terms based on like terms. So when I did the second row of multiplication, there wasn't a y cubed term, so that's why this is blank. But everything else, like these are my xy squared terms, these are my x squared y terms, and then that's just the x cubed term on its own. So make sure you line it up with the like terms. And then the last step is you're just going to add the columns together to get your final polynomial. So again, what you would do with long multiplication. So these added together, it's just plus 0, so it's just 4y cubed. When we combine these like terms together, we get positive 7xy squared, and then we combine those two together. So there's your final answer, making like in that last step, you've added all your like terms together. The next method is the horizontal method or the FOIL method. I call it FOIL, and this is what I use. FOIL stands for first, outside, inside, last. And it's an acronym you can use to remember which term should be multiplied when we're doing polynomial multiplication. So you're going to expand the polynomials by multiplying the terms in the order of FOIL. I've tried to do a color-coordinated explanation of this for my binomial times a binomial. So first means the first terms in each polynomial will be multiplied first. So in blue, I've kind of drawn the arrow here. It's going to be 4x times 2x. So first terms in each polynomial get multiplied. Then we've got the O outside, so the two outside terms. We've got 4x and -1. Those are on the outside. They get multiplied next. Then the I is inside, so the two inside terms, 3 and 2x, get multiplied. And then the L is last, so the last two terms in each polynomial get multiplied. Then this is just a bunch of monomial multiplication, which we know how to do. We do that. So we've got 8x squared and the rest of it here. And then your last step, like always, is to collect any like terms. So I've underlined that in gray. Those two combine to give you 2x. When you have polynomials that are bigger than binomials, you need a bigger acronym than FOIL, but the idea remains the same. You just multiply every single term in one polynomial by every single term in the other polynomial. So I've done an example like that here. We've got a binomial times a trinomial. So yeah, we can't use our FOIL acronym exactly, but I've tried to set it up with the arrows again. So I took the first term, 2x, and it gets multiplied by every single term in the second polynomial. So 2x times x squared, 2x times 5x, 2x times -6. So that's what I've put in blue. Then I'll do the next term, -3, and in green here, it's being multiplied by every single term in the second polynomial. And then, of course, we just have a bunch of monomial multiplication. We know how to do that. And then in our last step, we collect our like terms. So in the solid gray line, those are my x squared terms, they go together. And then the dashed line, the x terms, those get combined together. And as always, make sure your final polynomial is in order of descending power, so the highest exponent first, working your way down. So you can use this for any size of polynomial. You could do a trinomial times a trinomial. The question's going to get really long, but once you collect your like terms, it should be a bit smaller. The idea is the same though. The last method is the rectangle method. This is good for visual learners. And this is what it looks like. You're going to draw a rectangle to represent your multiplication with one polynomial as the length and one polynomial as the width. So we've got these two are being multiplied. So I've got the first polynomial, 2x minus 3, as one of the side lengths, and then 3x plus 1 as the other side length. Doesn't matter which one goes where. And you're going to split up this rectangle for each term. So that's why I split it into 4, because there's 4 total terms. So we've got 2x here and -3 here. So now I've got this rectangle that's split into 4 areas. So to get the multiplication of this, we want to find the total area of this rectangle, which we can find by finding the area of each of these 4 spaces and adding them up. So the area of space 1, well, that's side length 1 and side length 2x. So we multiply those two together. For area 2, it's going to be side length 1 and side length -3, so those multiply together. We repeat the process for 3 and 4. We multiply all our monomials together, and we collect our like terms, and we write it in order of descending power. So any of these methods are totally fine for you to use. I'm not going to ask you to use a specific one. Just pick one, or maybe multiple ones that you feel comfortable with, and then practice those. To end off this lesson, we want to talk about how we can check our work. It's easy to make small mistakes when you're multiplying polynomials, so it's important to be able to check your work to ensure you're doing things correctly. I've listed out the steps here of how you check your work. Essentially, you're just going to pick any easy integer value to replace the variables with. So I usually just pick 1 because that makes calculations very easy. So you're going to, in the original question, whatever you were given, replace the variables with that number that you chose and simplify. And then in the final answer that you just found, do the same thing and make sure those are equal to each other. So I've done that in this example here. I have my original question and I have my answer here. To check, I'm just going to replace the variable x with 1. If you have multiple variables, like let's say there's also a y in here, then I might also replace y with 1. So the first kind of check that I'll do is take the original question and replace the variable whenever it shows up with that number 1. Then I simplify. So 2 times 1 minus 4 is -2, squared is 4. Then I do the exact same thing, but with the answer that I just found, I replace all the variables x with my value 1 that I chose, and I simplify. When I do that, I see that I do have them equal to each other. They both give me 4, so I know that I've done this correctly. One other thing to note is in this question, it looks a little different because we have just one binomial, but it's to the power of 2. What that means is it's just that binomial times itself. So whenever you see that, which you will see, I recommend just writing out like I've done here, where you have the 2 sets of brackets, because then you can easily visualize which terms are being multiplied together. But of course, that just represents 2x minus 4 squared. So these are all the different methods we can use to multiply polynomials and how we can check our work.